I've created a Speed Manager class and I've gone ahead and placed it in the Manager's package, as you can see on the left. Our Speed Manager will be a singleton class, meaning only one can be instantiated globally. First of all, Speed Manager implements iAdvanceable. The Speed Manager class will manage the physics, if you will, of our game, meaning it will manage the different forces acting on our turtle, and it will also manage the speed at which the background and obstacles will pass by. Let's start our constructor function. If does not equal to L, throw new error, illegal instantiation of a singleton. Let's save some room at the bottom of this class by separating the next section with a commented heading called singleton. And under that commented heading, we'll have a private static var underscore instance, which will be this Speed Manager class, and we'll have a public static function get instance, and we'll return the Speed Manager. So if there is no instance, instance equals new Speed Manager and new LKR, which stands for locker and will be an internal class we'll create in a moment. Let's of course return instance, and let's go ahead and create this internal class. This internal class will have nothing inside of it, and as I mentioned, it's called LKR, short for locker. Okay, this will ensure that our Speed Manager class will only be invoked once. Let's quickly insert our advance function and return true. And let's create our variables. We'll mainly be dealing with 4 variables: xSpeed, xSpeed multiplier, ySpeed, and yForce. I've set xSpeed to gameSettings.gameSpeed, and xSpeed multiplier is a number class, as well as ySpeed and yForce. We're also going to be referencing a few global settings from the gameSettings class. These are going to be gameSettings.gravity, gameSettings.forceDecay, gameSettings.maxForce, gameSettings.xSpeedDecay, gameSettings.maxSpeedDifferential, and gameSettings.gameSpeed. Since our gameSpeed variable is already taken care of, let's create the remaining variables in the gameSettings class. We also need to remember to convert these using scaling factors inside of our init function. Let's go ahead and do that. Gravity equals getScaleNum, gameSettings.gravity, and etc. Also do the same for gameSpeed. And returning to our Speed Manager class, in our advance function, let's check if there is a vertical force, and if there is, we'll reduce it. So if yForce is less than 0, yForce plus equals gameSettings.forceDecay, and else if yForce does not equal 0, yForce equals 0. This else statement just makes sure that if we reduce our force into the positive range, we equate it to 0, so it doesn't go in the other direction. You can think of this as a simplified representation for gravity. And let's just quickly fix this. L is going to be passed through LKR, which I forgot to do earlier. And let's go ahead and calculate the integral vertical force. So const F number equals game settings dot gravity plus Y force. And let's divide the aggregated force by the frames per second. So y speed plus equals F divided by GUI module settings dot stage ref dot frame rate, which is just a pointer to our frame rate. And if there is a horizontal force, we'll reduce that as well. You can think of this as a simplified representation for friction. If x speed multiplier is greater than 1, x speed multiplier minus equals game settings dot x speed decay. Y x speed equals game settings dot game speed times x speed multiplier. Else if x speed multiplier does not equal 1, x speed multiplier equals 1. Similar to what we did before, we're going to make sure our horizontal speed multiplier equals 1 eventually, ensuring that if our x speed multiplier is reduced to less than 1, we equate it to 1. We'll continue Speed Manager in the next tutorial. Thanks for watching.